Hello and welcome to my lecture session on polynomials in MATLAB. I am Dr. Orijit Shah, Associate Professor of BP Poddar Institute of Management and Technology, Kolkata, India. What is a polynomial? A polynomial is an expression in which a finite number of constants and variables are combined using addition, subtraction, multiplication, non-negative whole number exponents which are raised to power. Now MATLAB software provides built-in functions for standard operations on polynomials such as arithmetic operations. Polynomial functions are stored in polyfun directory in MATLAB. How can we enter a polynomial in MATLAB? A polynomial is represented by a row vector in MATLAB and entered with variables, say f, terms arranged in descending order of powers. Only the coefficients of s are entered as elements of row vector and can be separated from one another either by a blank space or by comma. Leftmost term is the highest power term of variable s and the rightmost term is a constant term with s raised to the power of 0. We have to keep in mind the total number of terms is always one more than the order of the polynomial. MATLAB can interpret a vector of length n plus 1 as the nth order polynomial. If there are missing terms, zeros must be entered in appropriate places in the vector. For example, expression y equal to s cube plus 1 would be represented by the vector as follows: y equal to 1, 0, 0, 1. The 0, 0 is for a square and s term. It can be also represented as y equal to 1, 0, 0, 1. Both bears the same meaning for MATLAB. Two zeros have to be included in the vector. Now polynomial can be evaluated for a given value of variable, say s, by using the function polyval. The general form is polyval c, s. C is a vector whose elements are the coefficients of a polynomial in descending order of powers of variables s, and s is the value at which polynomial is to be evaluated. An example is given. Evaluate the value of the polynomial y equal to 2s square plus 3s plus 4 at s equal to 1. So we have to enter y equal to 2, 3, 4, the coefficients of the polynomial, and s will be 1. So value is given by polyval y, s. The result obtained is 9. How to evaluate the roots of the polynomial in MATLAB? It is obtained by the function roots p or r equal to roots p. Here p is a row vector containing the coefficients of the polynomial. So the coefficients has to be written out in a row vector, and that has to be passed as the argument of the command roots. It returns a column vector r whose elements are the roots of the polynomial. So we can find the roots of the polynomial s square plus 3s plus 2 equal to 0 simply by writing p equal to 1, 3, 2 and then get roots p. For addition and subtraction of polynomial, if there are two polynomials x and y, it can be simply added z equal to x plus y. Similarly, subtraction can be done z equal to x minus y. In both of the above operations, the dimensions of both polynomial vectors must be same. So if we want to add a equal to s square plus 2s plus 1 and b equal to s square plus s plus 5, so we have to produce the two coefficients and then add or subtract. Product of two polynomials is obtained by convolution operation of their coefficients using MATLAB function conv, and syntax is conv x, y. If there are more than two polynomials, then product is obtained by performing multiplication of two of the polynomials one at a time. Similarly, for division of a polynomial, deconv function is used. If two vectors are coefficients of two polynomials, then function deconv gives polynomial division and returns the quotient as well as the remainder. Syntax is simple: x, r equal to deconv z, y. Here z is the dividend vector, y is the divisor vector, x specifies the vector of quotients obtained and r specifies the vector of the remainder obtained. If roots of a polynomial are given as a column vector, then the corresponding polynomial can be obtained by poly. Syntax is x equal to poly r. Returns a row vector whose elements are the coefficients of the polynomial. How can we get characteristic polynomial of a matrix? Generally, characteristic polynomial of a matrix is obtained by solving determinant Si minus A equal to 0. Here A is the given matrix and I is the identity matrix. In MATLAB, characteristic polynomial or equation of a MATLAB is obtained by P equal to poly A. If we want to differentiate a polynomial, simple function is polydir. General form is dy dx equal to polydir y. Here y represents the vector coefficients of the polynomial whose derivative is to be obtained. Dy dx represents the vector of the coefficients of the derivative obtained. On the other hand, for integration of a polynomial, polyint function is available in MATLAB. General form is polyint y comma k or x equal to polyint y comma k. Here y represents the vector coefficients of the polynomial whose integration is to be obtained. K is the scalar constant of integration and x contains the result. Constant of integration k is assumed to be 0 until and unless specified. Integrate the polynomial y can be done like this. Polynomial curve fitting is a very important thing which we require in our scientific applications. If a set of points is known in terms of vector x and y, then a polynomial can be formed that fits the given points, and command used is polyfit. Here x and y specify the vectors of the points for curve fitting, k specifies the order of the desired polynomial, and command returns the coefficients of the kth order polynomial that fits the data in descending powers of x. How can we evaluate a polynomial with matrix arguments? Polynomial can also be evaluated for a square matrix S. In this case, the polynomial Ps equal to s square plus 3s minus 7 becomes Ps equal to s square plus 3s minus 7i, where I is the identity square matrix, S is the square matrix, and command is polyval m a comma s. Here A is the row vector whose elements are the coefficients of the matrix polynomials to be evaluated. A specifies the square matrix. With this, we come to the end of this presentation. Thank you for watching.